Hi, today we're going to talk about facility location, and I'll say just a few words about some common location factors. The text talks about many more. Then I'll talk about a couple of tools, or rather three tools, that we can use to help us make a better location decision. The first tool I'll talk about is the cost volume analysis tool, and this is a tool to help us determine which of several alternative sites is the best site um, given the range of production volume that we're expecting to experience. Another tool I'll talk about is a factor rating model, and that's a model for helping us pick a site based upon more subjective criteria. Here, the cost volume analysis tool, the criteria is cost. Down here, factor rating model, we have much more subjective criteria that we can consider. So you can think of these two as sort of complementary. And finally, another tool I'll talk about is the weighted center of gravity model. And this is a model which is based pretty much exclusively on minimizing transportation cost. So again, this is a fairly quantitative tool, also looking at cost as opposed to these more subjective criteria. But each of these is looking at a slightly different criteria or different aspects of cost in the case of the center of gravity and the cost volume analysis models, and helping us make a decision about what is the best facility location. So they are not mutually exclusive tools that could all be used in helping to reach the same decision. And actually what I'm going to do here in this video, this first video, I'm just going to talk about location factors and the cost volume analysis tool, and then in a subsequent video, the second video on facility location, I'll talk about the factor rating model and the weighted center of gravity model. Alright, so some common factors that we need to take into consideration when determining where to locate our facility, pretty clearly when you think about it, is where are our supply sources and where are our demand sources. So by demand sources, I mean customers. It can clearly make sense to try and locate close to your customers, particularly if you're a service operation. Wouldn't want to stick a restaurant out in the middle of nowhere, or a barbershop. On the other hand, if you're a manufacturing organization, you clearly want to be close to your supply sources, especially if you're transporting large quantities of material to your new facility, and it's expensive to transport that stuff. The closer you can be to your supply source, the lower the cost of manufacturing will be for you. But also you want to be close to your customers, because either you or your customers are going to have to pay for transporting the products to the customers, and that of course raises the cost of your product to them, whether they're paying for it or you're paying for it and charging them for it. In addition to these general costs, cost of trying to get stuff from your supply sources to your facility, and the cost of trying to get product from your facility to your customers, there are also site-specific costs. So some locations are just more expensive to do business in than other locations. And the nature of these costs can vary from being fixed costs, such as the cost of the land that you need to purchase to set up your facility. And that fixed cost is going to be pretty much the same year in and year out, regardless of how much you produce at that facility, compared to, say, variable costs. Variable costs are variable in the sense that the total amount of cost you incur depends upon how much production volume you have at the facility. So for example, if you double production, you might expect that the total amount you spend on labor also goes up by a factor of 2, or the total amount you spend on materials or on utilities goes up by a factor of 2. Some taxes, as you can see here, are also variable depending upon production volume, but some are fixed, such as real estate taxes. So these are all different factors we need to take into consideration in trying to determine where to locate our facility. What I'm going to do starting out is look at a model that considers these site-specific costs And then in the follow-up video we'll look at a model that considers the location costs, which are mostly transportation costs. Okay, so if we're looking at trying to pick between a couple of alternate sites in different locations, different cities or different countries perhaps, and the cost structure for each of those sites is different, or at least we think it's going to be different after we put our facilities together and get them up and running, then to pick the best site, at least with regards to site-specific costs, we need to do this analysis, this cost volume analysis. So in our example here, suppose that we have two sites, just calling them Site A and Site B, and we're trying to determine which of these two sites would be a best location for our new facility. We determined that the estimated annual fixed cost per year of Site A is $250,000, and that's much more expensive than the estimated annual fixed cost of Site B at $100,000 per year. However, Site A has a much lower variable cost per year. It's only $15 per unit that we produce at Site A. That's what we estimate it's going to cost us in terms of labor and materials and so forth. Site B, on the other hand, is a much pricier place to produce stuff once we're set up and ready to go. $35 per unit is our estimated variable cost at Site B. So that enables us to construct two total cost equations, one for Site A and one for Site B, and these equations tell us our estimated total cost per year based on our production volume Q. Big Q here represents how much we're going to produce in each year at our new site. Again, that's an estimate we're trying to figure out here as well. Given possible values for Q, how do these two sites stack up against each other? The total cost equation for A is clearly just our total fixed cost per year for A plus our cost per unit, $15 times the number of units we produce in a year. And similarly for B, our total cost per year is simply our total fixed cost per year, $100,000, plus $35 per unit times the number of units we produce. So if we wanted to figure out which site was best for different possible production volumes, one thing we can do is simply plot these two lines on a graph and sort of see which one is lower for different possible values of Q. And that's what I've done here on the next slide. I just went into Excel and put equations on Excel and created this simple little graph. And you can see that location A, which was the high fixed cost, low variable cost location. Here's the curve for A. Again, it starts out pretty high, but the slope is not very steep, and it is eventually surpassed in terms of cost by location B. So location B starts out at a much lower cost, but then when you get to this point right here, it looks like somewhere around 7,500 units of annual production volume, then location B becomes more expensive. So clearly, if this was the only criteria that we were making the decision on, we'd want to go with location B if we had low production volume. And then we got to this point right here, we'd want to switch over and instead be at location A when we had higher volume. So basically the decision would come down to, well, do we expect to be in this range of production volume at a new facility or in this range of production volume at a new facility? Now to get this exact crossover point here, we could of course determine this in our graph in Excel, sort of try and draw down the line here. Only of course in Excel we could do it with a little more precision. Okay, so to solve this manually, all we need to do is to set the two total cost equations equal to each other. So this is a total annual cost of Site A, and this is the total annual cost of Site B. And then just try and get Q over by itself and find out what value Q is the intersection point, right, crossover point between the cost function for site A and the cost function for site B. So it's fairly straightforward here in this example. We simply subtract $100,000 from each side, and subtract also 15Q from each side, and that gives us 250,000 minus 100,000 on the left-hand side, and then 35Q minus 15Q on the right-hand side. Again, when we subtract 100,000 from each side, the 100,000 is going to drop off over here. When we subtract 15Q from each side, the 15Q is going to drop out there, and we'll be left with this equation. Well, $250,000 minus 100,000 is 150,000. 35Q minus 15Q is 20Q. And if we just divide 150,000 by 20, we end up with Q equals 150,000 divided by 20 equals 7,500 units. So that tells us that this crossover point here, right here, is 7,500 units. And if we think we're going to be producing less than 7,500 units on an annual basis, we're going to want to go with location B. If we think we're going to be producing more than 7,500 units on an annual basis, we're going to want to go with location A.